section provides a brief introduction to cursors, a tool used to test predictive accuracy of models. This brief presentation was organized by Dr. Lemmy, narrated by Samantha Tone. In SQL Server, the cursor is used to go through data one row at a time, and for each row, we do a set of calculations. A row-by-row analysis of data is agonizing and time-consuming, but may be needed in certain types of analysis. A row-by-row analysis of data is needed when the SQL has to be adjusted, a field modified, and the SQL reran. One makes minor changes and sees how the entire SQL calculation changes. We might want to do this for understanding the sensitivity of results to specific assumptions. Or one might want to do row-by-row calculations to escape computational limitations that will not change the analysis of the entire data. A good example of use of cursors occurs when we try to use precision medicine. In precision medicine, one has to find a subset of data that fits the patient. This is hard to do, and use of cursors can allow for repeated SQLs that change one parameter to see if the fit to the patient improves. Suppose we want to create decision support for selection of antidepressants. The task seems simple at first. Find the antidepressant that works for matched cases in the database. In SQL, this would be done by calculating remission rates for different antidepressants matched on patients' features. The problem arises with matching cases to the patient. Since patients have many features, no case in the data may match the characteristics of the patient at hand. A procedure is needed that would repeatedly drop less relevant features and see if sufficient number of cases in the database match to the patient. This repeated dropping and rematching cases to the patient's features can be done using cursors. These slides show how we can do so. The use of cursors requires several lines of interrelated code. The first step is to declare the name of the cursor. Insensitive makes a temporary copy of the data in a file called tempdb. If scroll is not specified, then the next row is selected. If scroll is specified, then all fetch options such as first, last, prior, next relative, and absolute are available. The select statement is any ordinary select statement, but cannot contain into or browse commands. Read only prevents updates made through the cursor. Update defines updatable columns within the cursor. If column name is specified, only the columns listed can be modified. If update is specified without a column list, all columns can be updated. This is the syntax of the do while command. Do while command accomplishes the goals of cursor by increasing an index value at each iteration. Think of the index value as the row in the cursor command. The index value is typically declared as an integer, and since it is a constant, it must be preceded with an @ sign. Typically, the initial index value is set to 1. A while command tells the computer when to stop. In this case, we are telling the computer to stop after it reaches the maximum value. The begin command marks the start of the calculations. The end command marks the end of the calculations. After calculations are made, the index value is increased by 1. The code continues to work until the index value reaches the maximum allowed in the while command. Until then, the code loops back to begin and recalculates the variables, but now using a new index value. We demonstrate the use of cursors in context of repeatedly looking for different subset of cases in the databases that fit the patients at hand. Since our plans are a bit complicated, we have drawn an outline of how we want the code to function. We begin with initializing the data and concatenating all relevant features of the patient into one variable. If we have started with n features concatenated to each other, then we look up the cursor row and see which feature is scheduled to be dropped next. The feature is dropped from the all field by making both the presence and absence of the feature to have the same symbol, in our case a dash. We use group by command to re-examine subsets of data that match the modify all field. Since the modify all field has replaced presence or absence or one of the patient features with dash, the group by ignores this feature. In effect, we have redone the SQL and calculated it in a subset of data minus one key feature. We use group by command Suppose we have a patient who is male, diabetic, and has cancer. Suppose in our data we do not have anyone who is male, diabetic, and has cancer. We have to look for some other combination of features that we do have in the data. Let's see if we can walk through this code to see how we can try and match to a reduced subset of patient features. Since we have to examine the relationships of medications to remission across a combination of features, it's important to include data where the feature is present and absent. So we include three fields in our features: gender, diabetes, and cancer. Each of these fields can have two values. We concatenate these three features into one field, which we call all. If all the variables are present, we will have 111. If we have a code 010, then it means we have a female patient who is diabetic, but who does not have cancer. We look up the next row. We are now at row 1 if we're using a cursor, and at index 1 if we're using a do while command. We need to drop the first feature. We recode the all field so that the first character is always a dash. Now this feature does not change across the data. We now group by the all field and calculate the remission rate associated with various antidepressants in this subset of data. We now repeat the analysis and move the cursor to the next row, row 2. Now we drop feature number 2. As before, we do this by making it always a dash. Finally, after the all field has been modified, we redo the calculations and find remission rates associated with various antidepressants. In this step, the cursor moves to the next feature, so we're now at row 3. As before, we drop the feature in row 3, in this case cancer. We calculate which antidepressant is most associated with symptom remission. At exit, we have examined matches to 2 out of 3 features of the patient, and within these subsets, identified which antidepressant will work for the patient. Now let's look at the actual SQL code. This code was written to track the impact of 9 disabilities, gender, and age on mortality in nursing home patients. Now let's look at the actual SQL code. In the first step, we concatenate the features of the patient into a field called all variables. Gender, various disabilities of the patient, and age are converted to either O or 1 text characters, and then concatenated together using the addition function. We assume that in our data, no case fits these 11 features of a patient, and we need to select a subset of these features so we can find the relevant cases in our data. In the next step, we declare an integer variable called index. Instead of using a cursor that moves in the field of data one row at a time, we can use the index to track the row we're at. At start, we set the index to 1. We plan to go through all 9 disabilities, gender, and age. So we plan to do this for 11 patient features. Therefore, the while is set to maximum of 11 loops. We'll exit after the 11th loop. The stuff command replaces the character in the position of index to a dash. It is doing this when the feature is present or absent. De facto, the stuff command removes one of the patient features from the all variables field and stores the result in a field called cstrata. The group by command tells the computer to aggregate the data within all combinations of features except the combination where stuff command has changed it to dash. Note that since the dash is in all cases, group by command is not affected by it. The code ends with increasing the index value by 1, hence moving the cursor up 1 row. If we have reached the index value 11, then the code will stop. Otherwise, it will go back to begin and redo the calculations. This procedure de facto drops a feature until we find cases in our database that match the patient. The cursor on the do while command helps repeatedly execute the SQL code and finds numerous subsets of data that fit the patient at hand. Cursor and do while commands repeatedly execute in SQL code.